Hello! Today we're going to talk about the covalent bond a little bit more. And so, if you remember, last time we looked at how ionic bonds and covalent bonds are different. What's different about the actual bonds? What's happening with the electron? And which elements are diatomic? Pause it, think about that. Oh, yeah, you got it. Ionic bonds, remember, are a transfer of electrons. We have positive ions and negative ions, where covalent bonds both are trying to gain, and so they end up sharing those electrons. The diatomic ones, again, are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So the halogens kind of makes a little 7 plus hydrogen on the other side are our diatomic ones. Today we're going to think about some different kinds of covalent bonds or different strengths of them and what our structures actually look like. So we're going to use these structural formulas. If you think about the electron dot structures that we did before, where we did a dot for each valence electron, we're going to keep that idea, but now we're going to start to put multiple atoms together. And so in this, if you see a line, a dash or a line, that's going to represent the shared pair of valence electrons. And so that's a shared pair. That's one of those where both are trying to gain it and they end up sticking together because they're sharing. They're in a tug of war. We also can see the dots here. Those dots, that would mean that they are an unshared pair, that they were like when we did with our atoms, that they're just on the atom. They're valence electrons that are not being shared. And they do affect the overall shape of our molecule. And so we'll look at that shape more later. But so one thing we can think about, if we think about carbon having 4 valence electrons, in order to get to an octet, in order to get to 8, is going to need to make 4 bonds. And so we can see here carbon is going to bond 4 times with hydrogen. And so if we look at this, it's actually kind of interesting. Carbon can bond 1 carbon with 4 hydrogens, or 2 carbons with 6 hydrogens, 3 carbons with 8. They have some different names there: methane, ethane, propane, butane, pentane, hexane. And as we go, the bigger they get, they tend to be liquids at room temperature rather than gases. That's because the molecules are a little bit bigger and they start to stick together a little bit more as we go. So those are some different ways we can see it. We've got a name, we've got a structural, we've got a just the formula, the molecular formula. We've got the structure. We could draw out the whole thing, and then we could do like a ball and stick model. We could do it where we could look at kind of in 3 dimensions. We could do a space filling where they kind of look at like where are all those electrons just kind of in a big blob. It's probably the most accurate picture of one, and then but it's hard to kind of see everything. And then a condensed one where we kind of write them all to get down together. Those are different ways we could write our formulas. The big idea here is we think about 2 fluorine atoms. Again, covalent bonds are going to be nonmetal to nonmetal. So if you think about 2 fluorines, fluorine has 7 valence electrons, which means it really needs to gain 1 to get to 8. And so if this fluorine is trying to gain 1 to get to 8, and this fluorine is trying to gain 1 to get to 8, they're both going to try to gain each other's. And so we end up with a shared pair of electrons, which we're going to represent with that line. You can see here the orange and the green one are both trying to grab each other's electrons, and so the line represents a shared pair of electrons. And so that's why fluorine forms this diatomic molecule, F2. Likewise, oxygen has 6 valence electrons. So if the orange molecule here tried to grab a green one, and the green molecule here tried to grab an orange one, and they ended up sharing, that would be all fine and dandy, except that we have 6 on there. If they only were able to gain 1 from the other one with a single bond here, we still only have 7 valence electrons. We haven't gotten to 8 yet. So oxygen is going to actually try and grab this one over here too. It's going to try and grab an extra one And yeah, we didn't make it to 8. And so what's going to end up happening is we make this double bond where oxygens are actually going to end up sharing 4 valence electrons. Each bond, remember, is 2 shared electrons. So here's 2, and here's another 2 for 4. So 4 shared electrons is a double bond. You can think about how oxygen has 6 valence, so it's going to want to make 2 bonds in order to get to 8. Nitrogen, even more so. Nitrogen is it's got 5 valence electrons, and so thinking about 5 valence electrons, whoa, no, look at all those ones that nitrogen's not going to get to 8 just by grabbing 1 electron away. It wants more, and so it's going to make that double bond. And so, okay, that gets us to 7, but nope. It's going to need even more. It's going to need to share 6 electrons are going to need to be shared, and 2 are going to be unshared. And so that's, here we can see this triple bond is 6 shared electrons, and then these other 2 would actually kind of be on the outside. And that's a triple bond has 3 shared pairs, and so 6 total shared electrons. And so we can think about a triple bond is stronger than a double bond, which is stronger than a single bond, which is why nitrogen is actually a really pretty stable molecule. It's in the air. It's most of what's in the air, and it's really pretty non-reactive. We don't think about breathing nitrogen very often because it doesn't do anything. It just goes in, comes back out, goes in, comes back out, because it's got a really strong bond, and it's not very reactive. We can bond things other than just the elements to themselves. Oxygen, we're going to think about, again, it has 6 valence electrons, so to get to 8, it's going to try and gain 2, but hydrogen is not going to give its up very, very easily, so it's going to end up, again, sharing. So it can get 1 from a hydrogen there by sharing with that hydrogen, but that only gets it to 7, so we again need to share a second hydrogen, 2 H's and 1 O. So we end up with, there we go, the water molecule looks like this. Hydrogen, coincidentally, we talk about getting to 8. Remember that hydrogen is kind of sneaky, that it's going to have a full level with 2 because it's on that first level, and the first ring, remember, can only hold 2 electrons. So the first level is full at 2. Everything else is going to try to get to 8, but hydrogen only needs 2. So that's a little bit sneaky. You can think about carbon dioxide, another common one. Let's think here. Well, carbon has, let's think about the middle one first. Carbon has 4 valence electrons. And so, to get to 8, it's going to try and pull 4 electrons away from oxygen. So it could try and take them all from here, but oxygen's not going to let it. Oxygen has 6 valence electrons, so it's going to try and make 2 bonds. Right? It's going to try and grab 2 of carbon's electrons. So what ends up happening is, well, first they grab 1 from each. Carbon grabs 1 from over here. Oxygen grabs 1 from over there. They're pulling. Nope, can't get them away. But now carbon has 2, 4, 5, 6, so that's closer to 8, but it's still not 8. And oxygen has 2, 4, 6, 7, that's closer, but nope, not quite there. So in order for everything to work out, we need double bonds on each side. So that makes sense, right? Because carbon had 4 valence electrons, so it's going to need to make 4 bonds. 1, 2, 3, 4. Oxygen had 6 valence electrons. To get to 8, it's going to need 2 bonds. So 2 for this oxygen and 2 for this oxygen. Here's a couple to try. Think about how those are going to bond together and draw the electron dot structures. Go ahead and pause it, give it a try, and then I'll show you some answers on those. All right, here's what I got for number 1. I got HF. Remember that hydrogen only needs 2 valence electrons, so just the bond is good for hydrogen. Fluorine had 7 valence electrons, so 6 unshared electrons plus the bond makes 8. 7 it brought, and making 1 bond is all it needs to get 8. For number 2, sulfur had 6 valence electrons, so it's going to want to make 2 bonds. Again, hydrogen can just have the bond and it's going to be happy. So if sulfur makes a bond with each hydrogen, that's its 2 bonds, and we're good. And the last one is a little bit trickier. Nitrogen has 5 valence electrons, so it's going to want to make 3 bonds, and then it's going to have those 2 unshared pairs at the top. 2 unshared electrons, 1 pair. At the top, chlorine has 7 valence electrons, so each chlorine wants to only make 1 bond. There are 3 chlorines there. So if we think about nitrogen, if we're counting them, we have 2 from the bond, 2 from the bond, 2 from the bond. That's 2, 4, 6 electrons, plus its unshared pair makes 8 total. Everybody's got 8 total, and everybody is happy. Have a great day. Good luck.